Hey everyone, let's jump right in. We're going to talk about something fascinating today. How nature has been cracking the toughest problems for millions of years. The same problems we're still wrestling with. It's a world of absolute genius, hiding in plain sight.
So let me just throw this out there to get us started. What if our proudest achievements, our incredible engineering, our life-saving medicine, all our tech, what if we weren't the first ones to the party? What if we're just rediscovering solutions that have been out in the wild for ages?
See, when we think about solving big challenges, we tend to put ourselves at the center of the story. But the reality is, natural selection has been running the world's longest, most intense R&D program for billions of years. It's a design lab that never ever sleeps, and its blueprints are literally all around us.
So where do we actually see this stuff? Well, let's kick things off with Section 1, Nature's Master Builders. We're talking about engineering marvels that were built long before humanity even showed up.
Okay, imagine you're an engineer. Here's your task. Design a massive structure that keeps a perfectly stable temperature inside, day and night, in the scorching heat of a savanna. Oh, and one more thing. You can't use any electricity. At all. Sounds completely impossible, right?
Well, guess what? Termites figured it out. Their mounds are absolute masterpieces of passive cooling. The system is so simple, it's brilliant. Basically, all the hot, stale air from the colony rises up and out through a central chimney. This creates a vacuum effect that pulls cool, fresh air in through tiny pores in the outer walls. It is a perfect, self-regulating, zero-energy air conditioning system. Architects are studying these things right now to build better buildings for us.
All right, let's switch gears to material science. The challenge here, create something super lightweight, really flexible, but also unbelievably strong. Now, we came up with steel, which is pretty amazing, but spiders? Spiders had us beat by millions of years. Pound for pound, spider silk is actually stronger than steel. It's this biological supermaterial that can absorb a crazy amount of energy, which is, perfect for catching a bug flying at high speed.
And the list just goes on and on. You've got mollusks that build ultra-tough shells out of simple minerals found in seawater. Or think about woodpeckers. They develop some of the most advanced shock absorption in the world right in their own skulls, a design that's now inspiring better football helmets. It's everywhere you look.
But nature's genius isn't just in building things. In Section 2, we're going to look at ancient social networks and see how animals solved massive organizational problems way before we ever thought about cities or the internet.
Okay, take a good look at this timeline. We humans started farming about 10,000 years ago, and we call it the dawn of civilization. But ants? They had it mastered 50 million years ago. Just try to wrap your head around that time gap. It's absolutely staggering.
And we're not talking about simple gardening here. Oh no, leafcutter ants are incredibly sophisticated farmers. They grow specific types of fungi in these huge underground gardens. They manage pests by carrying around good bacteria on their bodies that produce antibiotics. Yes, you heard that right, antibiotics. They even selectively breed their fungus to get better crops. It's an agricultural system every bit as complex as our own.
So how in the world do they coordinate all this activity? Through some seriously advanced communication. A honeybee's waggle dance isn't just a dance, it's a symbolic language that tells other bees the exact direction and distance to flowers. Dolphins use clicks and whistles that act as a sonar system better than some of our own mapping tech. And ants, they leave pheromone trails that create these complex, efficient routing networks, basically using the same principles that guide traffic on the internet.
This all brings us to Section 3, the ultimate survivors. Now we're going to see how nature tackled huge challenges in medicine and even energy storage.
We usually think of medicine as a uniquely human thing. But it turns out tons of animals practice what scientists call pharmacognosy. It's a fancy word, but it just means they deliberately use things in nature to medicate themselves.
And some of the examples are just wild. Chimpanzees will find and swallow these specific rough leaves, not for food, but to literally scrape parasites out of their gut. Get this, woolly bear caterpillars, if they get infected with a parasite, will start eating toxic plants on purpose to kill the invader. And some birds practice something called anting. They grab ants and rub them on their feathers to use their natural chemicals as an antibiotic.
Now let's talk about energy. Look at this number, 600 volts. That's not coming from a wall socket. That is the charge an electric eel can generate. They literally evolved biological batteries, made from special cells called electrocytes,
all stacked up just like the cells in your car battery.
And this isn't just some fun piece of trivia. This is huge. The elegant, powerful system inside an electric eel directly inspired a guy named Alessandro Volta to invent the world's very first modern battery, a direct line from nature to one of our most foundational technologies.
So what does this all mean for us? What's the big takeaway? That brings us to our final section, number 4, humanity's next blueprint, where we look at how we can start learning from all this genius.
This quote from our source material really just nails it. Evolution isn't just some random process. You have to think of it as a 3.8 billion year-long experiment in problem solving. It's constantly testing, tweaking, and adapting to find out what works best.
And there's actually a name for this whole idea. It's called biomimicry. It's the conscious effort to look at these time-tested patterns in nature to solve our own problems. It's all about stepping back and asking a simple, powerful question. How would nature solve this?
And why should we do this? Well, because as we've seen, nature's solutions are often way more efficient, way more resilient, and naturally more sustainable than anything we've come up with. They are the result of millions of years of trial and error, of refinement. They've been beta tested on a planetary scale.
So I'll leave you with this final thought. As we face our own massive challenges, climate change, resource scarcity, you name it, maybe the most innovative thing we can do is not to invent something new from scratch. Maybe it's just to finally pay attention to the answers that have been all around us all along.